So this is the Patreon only release for the Dynaco. That the tubes went in and it started popping the fuse right away. So I had to I started troubleshooting on this thing because I didn't realize that I was dealing with a defective tube. And of course the fuse popped before anything came on. So I went through about 4 or 5 fuses, and I'd pull the tubes out and start testing things, and well, one thing led to another, but we're going to do a little explanation. I actually did a reverse engineering of the bias board, and we'll go through that because I filmed it. So inadvertently, my camera was running when I thought it was off, so that's what that was all about. But let's continue. Well, that was kind of a waste. I was recording and didn't realize it. We'll have to edit that out. We're having some problems with this amp. I've got the original tubes back in because it started acting up again, and now it's actually staying acting up. So I'm measuring my voltage going, and I'm on my current limiter right now. This tube is going into full conduction, but it's because this tube here is not going into conduction. Minus 23 volts there. And I've got plus 8 here. Over here I've got minus 21, and I've got minus 21. This one here is... Now notice I'm using the original tubes in this thing. I put all the old ones back in when I'm troubleshooting it here, and it's not working. But if you look at the tube just over my right hand, you'll notice it's not in right. That's because the socket is actually damaged, and it allows the tube to go in the wrong way. Now, if we go back to the very first shots when I first pulled out the tubes, take a look at the 2 tube sockets on the right. They are damaged, and the tubes will actually go in out of alignment, and that's exactly what happened when I had the unit sitting on its back, and I put the old tubes back in. I just kind of rotated them until they dropped into place. Well, as you'll see, one of them was out of whack, and that's what caused my bias readings to be out when I was trying to get bias readings with all the old tubes. As when the new rectifier was in, it blew the fuse immediately, so I went back to the old tubes for testing. Power it up now and see whether my voltages look a little more normal. So we'll watch the B plus as the B plus comes up, because I was only getting like 5 volts B plus because the tube, one of these tubes was going into full conduction and clamping down on the power supply. So there, our voltage is going up now. That's good. That's better. It was actually this tube here that was going into conduction. 198, that's better. And here's where my bias was kind of screwed up before. One of them had a positive voltage. This one had the negative voltage, and on this one here, we still don't have any voltage here on this tube. This tube is not going into conduction whatsoever. Now these are the old tubes that are back in this unit too. I put the old ones back in just for testing. Let's take a look at the actual bias circuit. I just reverse engineered this in my head and drew it out so we can get an understanding of just how the circuit is supposed to work. So let's take a look at my drawing. Basically, the switches will switch pin number 4, one of the grids, G4, I guess it is, or G3. You got your cathode, G2, G3, G4 is connected to the cathode, and then your plate. So anyway, G3 is switched either between a center tap on the primary of the transformer for ultralinear mode, which is in pentode mode basically, or you connect it to the plate through a 100 ohm resistor, and then it becomes a triode, because then the only active grid is the control grid, which is your G2 off of pin number 5. Your audio signal comes in here. You know, this is your signal that's being amplified. Comes in on pin 5. Positive tube and negative tube. These tubes are biased. So here's our bias circuit. We have our negative rectifier here, AC coming into our negative rectifier. Our bias capacitor will give us our negative bias voltage. It goes through a 7.6K resistor, which will connect to both of the bias pots. These are the bias. these are the bias pots, which are, I'll show you on the board here in a minute. Anyway, and then the other side of the bias pot is going through and I neglected to draw it in here, but there's a resistor in here. And then it goes to ground. And that resistor is what value is it here? Just give me a sec. So 27K to ground. So anyway, let's look at this this problem I'm having with the voltage and see where we're losing, or where the bias voltage is getting kind of messed up, because one tube here, the grid is going positive. This should be negative, right? The control grid is held negative, because if this goes positive or even close to zero, this tube is going to avalanche and go into full conduction, which is what was happening on it. And on one side, and the tube that was actually going, the one that had the bad getter on it, and it was the one that was appeared to be going into conduction, looked to be that one, but doing testing, it's not that one, it's this other one that's going into conduction. So if we measure some voltages here, nice little light that I made up, right? So we can get this light in here and see exactly what we're doing. If we measure some voltages, if I turn on the power, and we'll look at the voltages here. So this is our negative 55 volts. This is our solid state rectifier for our negative bias. And here's our negative 43 volts here. Our bias voltage comes up minus 43 here, minus 43 here. Here's our negative bias voltage, minus 26, minus 26, and now this side is 0. This is going to the tube. On the other side here, it's minus 16. So this is our problem. This tube is not getting its negative bias voltage. 0. Why is it 0? Is this cap leaky? Could be this cap that's gone leaky. 75 volts on this side of it, which is the same as on this one over here. Right, 75 volts. Yeah, but on this side here, it's at minus 14, and this one here is sitting at 0. Now I wonder if I unplug this tube, whether the voltage will go up. This is an old tube that's in here now. Oh, so this tube here might be bad. This is one of the old ones, but I had the same fault when I put the new tube in. The tube went into full conduction. Now my negative bias voltage is there on both tubes, but when I plug this tube in, the negative bias voltage drops to 0. We'll just try one of the tubes from the other channel. So I just switched these two tubes around here. We'll see whether my negative voltage comes back or whether it stays down at 0. This thing warms up. Oh, might help if I connect my ground wire. Looks like it's drawing too much current again. Negative 15 volts. Now I got negative 16. Okay, did this one go bad? Is this tube bad? Minus 14, that's fine. See, now this stupid amp is working. My negative voltage is correct. Unless I got a bad socket. That is so bizarre. Because you guys just saw that a minute ago. That was 0. All the components I've checked so far are good. I haven't spotted any bad connections. I mean, some of these don't look terrific, but I haven't seen any connections that are actually, really bad. Oh man, I feel kind of silly here because this is something you don't see. I should check this whenever I work on tube stuff, because you never know who's been into it prior. It's the tube socket. observe. See, normally tube sockets are constructed in such a way that they have an indexing pin right here, so that the tube will only go in the socket in one direction. You can put it in any way, but the tube will only drop in its correct orientation. Check out this tube on this side. The hole is bigger than the tube socket, the index pin. So when you drop the tube in, it'll go down in any position. And someone's done that. Someone's forced it in, and it'll go down in any position. And silly me, when I put the tubes in, I just kind of went and I popped the tube in, and of course it dropped down. I didn't check the orientation of it, and I was like, what the hell? And someone's done that before. See? They've jammed the tube in the wrong way. So on this amp, you have to really take care and make sure that the tubes are in the correct orientation. Because on this side, these tubes will go in the wrong way. And if the tube goes in the wrong way, it's not going to work. So now the tubes are in the correct orientation. Let's fire this thing up and complete the bias. That's what this video was to do the bias. Okay, let's set the bias on this bloody thing. We're going to ground our probe on one side, and we're going to measure the bias voltage here. It should be 0.4. It's been running now for about half an hour warming up. Got 0.5 volts, so we're going to drop this down to 0.4, whichever one's the right one for this. There we go. 0.4 volts. So at this part, the video is the same as the public one where I went through the bias, so you guys could watch that one and see the bias setting. I just wanted to put out this little extra special one because this amp, I was staring at this thing for a while trying to figure out why. Well, first of all, why was the freaking thing blowing fuses? And, well, it's the rectifier tube. This is the old rectifier. In fact, this is all new tubes now except for the rectifier tube is the old tube. And that rectifier tube actually is bad because the first time this thing came in, it was sparking. So if I were to tap this tube, it will spark. And we'll see it because right now I'm running the thing with no fuse. I've got a current jumper in place so that I can operate the thing without it blowing up. And I've got the current limited to the bench itself. But if I get that tube to short, we'll get some smoke out of this thing because my jumper wire that's under the chassis is going to smoke. So we'll have fun with that. But I get this thing all set up, and then when I was testing it, I'm going to give that tube a little thump. Again, that was taken out of the public one, so you guys can see some smoke coming up here. But this tube here is bad, and it needs to be replaced. But the replacement that we got for it was dead, completely dead. And it threw me for the longest time that we had a completely dead, brand new rectifier tube. And when I first plugged it in, the owner of it was standing in the shop, and I plugged it in and it popped the fuse right away. What the hell happened there? And so then he took off, and I started testing it. And a couple of hours later, I find that the new tube is no bloody good. It works with the old tube, but the old tube has got an intermittent problem with it, and if it shorts, it'll pop the fuse. So right now, we're running it fuseless just for testing because I don't have an endless supply of 3 amp fuses, and they're bloody expensive. So every time I pop a fuse, it's like 50 cents, right? So we'll set it up like this. Let's say got the bias all set, but let's see some smoke. Okay, there we have it. Some music plugged into it now. Okay, ready for the defective tube to go? Here we go. We're going to give it a tap right now. And that was my jumper wire that just became a fuse. Burned up in the back of it. Yeah, so that tube is working, but again, that's why that tube was changed in the first place, because that tube has a problem. But the new tube that we got, well, it doesn't even work at all. Okay, let's take a look at it with the new rectifier. Basically, I got a slow blow fuse in, so it's not going to blow the fuse this time, but it's not going to work. And then we're going to change the tube back to the old one and get sound. So here is the amp on. You can see my light. You'll see this thing start to flicker when it starts to act up, and you might even see some sparks in here. But we're probably never going to get any sound out of this thing. This is the new 5AR5 that's in there, and I'm going to cut the power immediately as soon as this thing starts to arc, because I know it's going to arc. There. Okay, that's the new tube. Power off. Go back to the old tube. We know it's the old tube because I marked it with an X. Back to the old tube. Power on. Now this tube, if I tap it, it'll spark. This one we know because it was bad before. I got sound. Impressive, huh? Back to the new one. See? Brand new. $50 tube. DOA out of the box. Thanks, Russia. You can see the old one. Well, you can tell the old one because it's darker, the brown. But this is it's got a new date code on here, a newer date code. But anyway. You have no idea how many hours was wasted chasing down a non-existing fault that was caused by a brand new tube. So there it's running. It's got the original, I think it's a GG tube. It's a Chinese tube anyway. That's the original one that's in here now. And the tongue saw, that's the original tube, right? And the tongue saw tube, this is the new one that's NFG, right out of the box. That happens once in a while, but unfortunately, when you buy a tube, the shops never will reimburse you, even if it's defective out of the box. You buy them and you spend the money, and if it doesn't work, it's too bad, so sad. Unfortunately, that's the way it is in the vacuum tube business, the vacuum tube market. You buy one, if it doesn't work, oh well, you bought it, it's yours. The warranty ends when you pick it up off the counter, basically. Okay, that's it for the Patreon release. As usual, thanks for your support, and please don't share this link with anybody else. This is a private file for your use only.